This problem says the population P is initially 450, so that's your initial value. Suppose that at each time period X, now they're not telling us how long the time period is, they're just saying at each time period, the population increases by 200%. Find C, the initial value of the population. So it says find the initial value of the population. That, of course, is 450. Find R, the growth or decay rate. Well, the growth or decay rate, they told you, is 200%. So the growth or decay rate is 200%. I'm sorry. The growth or decay rate is 2.0 or 2. And now this is where it gets tricky. It says find A, the growth or decay factor, meaning what do you multiply it by to get to the next thing? And the factor, you always add the rate. It's always 1 plus the rate. So what are you adding to get? What's your growth factor? It's actually 3. Your growth factor is 3. So again, let me explain that maybe a little bit more clearly. A growth factor is going to be 1 plus whatever your growth rate is. A decay factor would equal 1 minus whatever your decay rate is. So if I said that it was increasing by 100%, if it increases by 100%, if the rate of increase was 100%, what would that mean? If I said, hey, it increases by 100% every 2 years, it would be that would mean that it doubles every 2 years, right? In other words, the factor would be 2. So if it says it increases by 200% every X time period, that means that it triples every X years. And that's why our growth factor is actually 3, not 2. So it's a little bit tricky. It's a little bit tricky to think through that sometimes. So it says find an exponential growth or decay model in terms of the number of time periods X. So here's how this works. P of X equals, you start with your initial population. There's 450. And then you take your growth factor, which is 3. Yeah, and then you raise it to the X. That's right. So every X time periods, it's going to triple. You're going to multiply it by 3 every X time periods. So let's do a little table over here and see how that works. Here's X, here's P of X. After one of these time periods, what's your population going to be? It's going to be 450 times 3 to the first power, which is just 450 times 3, which is 1350, I think. After 2 time periods, what is that going to be? It's going to be 450 times 3 twice. In other words, multiply that number that you had here, multiply that number by 3 again, and that'll be that one, and you'll see that that's how that works. And you don't even have to, it doesn't have to be an integer, it could be a 1.5. You could raise it to the 1.5. One and a half of those time periods, what's your population size going to be? Just multiply 3 to the 1.5. And by the way, you have to be careful when you do this. Make sure that you punch it into your calculator, or that you know how your calculator thinks through it logistically, because you don't want to be raising the wrong thing to the power.